Hello again. It's Damon. Crazy Logic 007 on YouTube. Crazy Logics on the forums. Uh, got all the FETs off, and if you can see, we got a little charring over here. That's from this blowed up FET and one of this. This is the 3 dead FETs. So we got a stack of FETs that I put on a little tester. That all checked very similar to each other. So depending on what you were doing, technically you could have so the way these are arranged, when I flip the board over, you'll see that the 4 in the middle all get the power in the same spot here, or done here, and then you got the 2 on the end. So it's this is a pair for this output drive circuit. This is a pair, and so there's a chip and a chip, and then there's a chip and a chip for this pair and for this pair, and that's the high and low sides. I couldn't tell you which without looking at it real good here, but so technically, if we'd have taken these out real careful one at a time, set them out, checked them, and found, obviously these 2 were dead, but one of them was dead over here. We could have just removed that group and left if the front groups of these were both good, and then just replaced those. However, we're not doing that in this case because I know that this amp is a guy that competes in SPL stuff, and so we are going to go ahead and replace them all so they're all matched, so we don't have any discrepancy between when these were manufactured and when the new ones will be manufactured, and we don't take the chance that one of those took kind of a hurting whenever these blew and this amp shut down. And we're going to replace all these chips. We always do that on this style board. That chip is notoriously weak when something blows, and the safe bet is just to go ahead and change them all out real quick. And so we're going to pull this board, and we're going to clean this up, make sure everything looks good there. So I ought to be doing that while I'm sitting here flapping my jaws. I do have the fan on. There's some background noise maybe, and I got the garage door open, so if we get some cars passing, I'm sorry, but it is summer. I am hot. It's after a long day at work. I'm trying to get a little bit of this done because we are moving, and I've got tons going on, and I need this thing done out of my way. Now there's some goo that was right here that I noticed. I don't know if that's just, yeah, it looks like it's the same residual goo up here, so I wanted to look at that. I'd noticed that when I took out all the FETs before I went to bed. So we just want to make sure that this cleans up here, and that way we can get a good reading. These resistors look okay. A lot of times when the FETs blow, they will wipe out these resistors right here. Let's get a pointing device so that you can see. So, and let's tilt this up. So these resistors right here, those are 47 ohm, and they are the gate resistor or drive resistor. So they come from this chip, they go down, and they drive each FET through that resistor. So but they look intact. Normally they'll get pretty crispy. I think the only soot we had was because that one exploded out there. And so anyway, I want to go over real quick a few things we're going to always want to check. So we're going to test every one of these 47 ohm resistors, and these are actually high precision. So it's a 4, 7 black, and then a gold and a red band, so they're like 1% tolerance or something. I'd have to look it up to be totally exact on what that means. But I know they're high precision, so we don't want these straying hardly at all from 47. They should all be matched. If we find some that are not perfect, then we may, depending on what I have for replacements, I should have some high precisions. If they don't match in the batch exactly, I want matching ones all through here so they drive all the FETs equally. You want them really, really close so that these things turn on. When you're doing high power, especially like competition, it is important to try to match these components absolute best possible. And so something I was going to say about these is if you was doing a poor man's rebuild and you were willing to risk, because it was just for your daily driver, you weren't into competition, you were willing to risk leaving some and just replacing the bank, you still want to check all these and make sure these are really good, everything being matched. You cannot mismatch parallel components. So the way these are set up, these four are banked. There's a, I'm going to call this the high side, this the low side. Actually, I'm going to call this the high side and this the low side. It's most likely these four in the middle are the low, based on other amps. But so, you know, these two have to be matching manufacturing dates. And then these two have to, and these two, and these two. And they really all need to be matching. And in a competition amplifier, if somebody's using it for that, you really want to make sure. So we're going to put our meter over here. I'll see if I can get it done. Now, it's important to keep these that end up being checking okay. I used my little checker. You can get these. This is the raw one without a case. You can get them. You can get them on eBay and you can get them on Amazon. But I'm going to go, and we should see. You can see 47 ohm. Let's see if I put this up over here. A little better. 47.1. Like I said, I'm looking for them to all be, you know, 46.9 to 47.1, maybe 47.2, because there's a low resistance in my lead. So they all got to be right in there. I don't expect them to be off more than a couple points. 47.2 is the highest we've seen. Oh, my big fat arm's in the way. Yep. 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 And those were the ones I was worried about over there. Those were the ones in the discolored area. And then I was worried about one over on this side, you know, where we blew one fit on this side too. So everything is looking. 47.1, 47.2. Everything looks pretty good there. We need to test these other resistors. These are the pull down resistor that helps turn the FET back off once it's been turned on. And they are 10K, but they're not going to read 10K because they should be paralleled up into some groups. So they are, and they run in through the rest of the circuitry. I'm trying to think of how the easiest way to explain it. But first of all, if you just measure them on 20K, right? Yeah, there we go. Oh. Let's try this next one. Do I need to be on a higher K? 49. Hold on. Maybe I ought to get my glasses out. I thought those were 10K. Aren't those brown, black, yellow? Yeah, that should be 10K. 49. Is that 100K? Is yellow 100K? 1, 8, 49. Yes, that would be right, about right. 49. That's a little low. 40. 41. And the reason why is there's another 48. 48. 48. Might be the difference between the high and low. 48 is it, so if this is the high side, these two ought to be reading 48. Yep, they are. My arm's in the way probably. 48, and then these are going to be reading down towards 41. And that's the other components that are paralleled up with them. So what we're looking for is an aberration. So that's good because all those were the low side, those were the highs, and they all matched up. We also need to check these resistors here. These are like a point, I think they're 1.5 ohm, or sorry, 1 ohm, 1.2. Yep. 1.2. These are high tolerance, fire resistant. These are, I can't remember what the heck they're called. And then we need to check these little green inductors. These are actually inductors. Some of them will be paralleled up sometimes. So they normally, like there's some here way on the edge of the board, they should read roughly 5 ohms, but you can get divisions down depending on how many of them are side by side paralleled. So these are both reading 5. This one is reading 1.5. This one's reading 5. This one's reading 1.5. That one's reading 1.5. That one's reading 5. And this one. So I got 4 of them that are reading 1.5, but let's go on one side of the inductor and go to the other one that's reading 1.5 on diode mode. Yeah, and the other one that was 0.5. So those are all connected in the same spot on this end. Let's see if they're all connected to the same spot on this end. Yeah. Yep. Yeah. So those 4 are actually all in parallel. So if you take roughly 5 ohms 4 times, that would be 2.5, and then you divide that 1.25 ohms is roughly what you should read. And we were reading about 1.5, which, you know, you take into account your leads and you're pressing against, you're not soldered all in and stuff. So those all appear to be good. So the only thing we got to do is take this board out. And I've looked at this board right after I got these done, and I was looking for damage on these, and I did not see any damage on those chips. And I also looked down here to see there's caps and stuff. When I get this board out, I'll fade to the next shot. I'll get this thing flipped over and get it prepped for taken out, because I'm trying to condense the size of these videos a little. If you guys want them long, let me know in the comments you want them long, you want to see absolutely everything. But I'm trying to condense them down because, you know, my view times show that people are skipping around and getting straight to the point, and they're not always caring about everything. They just are looking for specific stuff. So I'll try to shorten them down. But everything really looks good. I got a funny feeling that whatever caused this amp to die, the protection circuit caught it real quick, which is really lucky, because they don't always. They can die in a point where it just happens to not be where the protection circuit can kick in quite fast enough, and stuff can go crazy, pow, 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 pow. But we may have got lucky that maybe one of these got slightly damaged, whichever this was like the weakest link, and started to go, and they happened to be turning their volume down at that time or something like that, or the fuse popped quick enough. You know, you just never know. I don't know, because I don't know what happened with this amp. I know it was in slave, and I know all these were turned off, which is how you set up a thing for slave, because once you slave it, you don't use any of these controls. You're supposed to turn them all off, put it in slave mode, and then the signal comes out of the other amp and into here, right over here, this other RCA, and basically what it does is it inverts it over to here, and turns this into a, you know, because they're both a mono, it's just like a two channel stereo amplifier that you bridge, but you're using the output from one to come in over to here to give you an inverted signal, and then they become bridgeable that way. So one runs the negative and one runs the positive wire. And so you have to look up how each manufacturer tells you to hook it up down there, the speaker ends, and set all the settings and everything like that. But I think we got super duper lucky, and we just caught this thing's protection circuit kicked in really quick. It caught it before the damage was too bad. We're going to replace these as safeties, but everything else is looking good. So cross your fingers. We'll be able to do that, replace those real quick, and I want to show you how I do this the way I think it's best, because it exposes these chips to the least amount of heat when you put the new ones on, so that ensures that you should have the best chips on there for survivability that's possible, and then we'll put new FETs in. But before we do that, the reason why you want to hold on to these, even if they're good, you know, I'm not going to use them. If I built, you know, had my own personal amplifier and I blew some, and I had, you know, maybe it was a little smaller and I had enough of these to make match sets and it was just for me, or a buddy that just said, man, it's not really his favorite amp, but he just wants to slam in his, in his junker car or something, and he's not wanting to put his good stuff in there. I might reuse these, but actually what I keep them for, what we're going to do is we will tack down these ones that say they're good. We'll put, since that's a bank and a high side and a low side, and a high side and a low side, we only need one FET in for testing of all the banks. And so we will actually use these, and we will tack them in on top like this. And I'll dab all those in solder, so you'll see one FET in each bank where it needs to be. Once we replace the drivers on this board, we will be able to test with that in and make sure we get all the correct drive signals. And just if something happened to be wrong and it went boom and blew up a FET, it wouldn't be blowing up our brand new nice ones that I've got over here. That's an all nice match set. So we can test this way for all the drive signals and output, and we could even technically hook up a speaker and run just a really, really quiet signal through it, and just to hear it play for 1 second. And that will allow us to know that everything's good here. We got all the correct drive signals, and it's safe to put the new FETs in. And so that's what I'll save these for, always as sacrificial tests, just in case I screw up. Everybody screws up, especially me, because I'm a goober. But that way I'm not putting that nice brand new match set until I've got a chance to test and confirm that all the drive signals are good, nothing else went squirrely, and we've tested everything and it does work. And then will feel safe and confident to put all the new ones in, slide it into its heat sink, fire it up, check it, run a signal into it, and do some tests. And so that is the advantage of having those extras. And you can, if it's your own personal one, you can reuse it. I never would put this in for somebody who wants a real repair. Like I said, I'd do it for a junker amp that happened to use these that maybe wasn't somebody's favorite, or if it was my personal one, or if I ended up getting one of these that had burnt up the board real bad, and so the person just said they didn't even want the amp, then maybe we'd refurbish it, in my spare time with matched up sets to get it up and running, and just give it to somebody that needed a backup amp or something. I'd love to find a couple of these like this that would get donated to me that maybe were in a bit of rough condition, that when I do get extra time, I could rebuild them with some older parts, get them 100% functional, and then have them as backups for taking to some of these sound off shows. I'm not a big SPL guy, but it's kind of fun, and it's kind of fun to go see everybody's car, so I normally go for a few hours. But it'd be cool to have something that if somebody popped a amp, you could say, hey, here, you can still compete, here's you an amp. And that way your weekend's not ruined, and the guy can get through his competition and have a little fun. And you can just tell him, hey, whenever you finally get your ramp repaired by, if it's under warranty or by a shop or whatever, then you can bring the amp back to me, or give it back to whoever. I'd like to give these to a couple of the car stereo shops and have them where if they had a sponsored guy or a guy that kind of goes for their shop, they would end up having a backup amp or two that they didn't care if it got blowed up again. It'd just be like, let the guy finish out his day, and have fun. Because really, what is this all about? It's enjoying your music and having fun. And so I'm having fun being able to fix them. It's a super fun hobby to me, but I'm kind of a nerd that way. So I'm going to flip this sucker over, and I'm going to get this prepped and mostly desoldered, and I'll show you what I do, and then I'll show you how to do the little wiggle trick that Sam Bear Vids always does to make sure that he's got it all loose so he doesn't pull vias. It's a really brilliant little trick that you can do and make sure this just slips right out. Then when we have this board laid out here, I'll show you that trick. We'll cut to almost ready to do that. Then we'll cut to this board being the only thing here. We'll get this amp up out of the way, and I'll get zoomed down as best I can, and I'll show you. We'll hot air remove these, and then I'll show you how I install them so that they get the least amount of heat into them. I love the way to do this. I do all my chips this way. My favorite way. It seems to work excellent. So I want to share that, and then we'll get that board back in. We'll put test FETs in, so I'm pre-warning you where the cuts are. We'll give it a quick test to make sure all the drives are good. Then we'll pull those out, put all the good ones in. As long as everything's good, we'll get her back in the heat sink, get her tested as best we can. So that's the plan. Hang on, look for the cuts. Here we go. Okay, I'm trying to set up good camera shots. Up in the corner should be a zoom in. This is, I've already done the outside rows here, and I'm going to show you how I do it on this little inside row, and then I'll show you the wiggle trick, which works real good. So, I've got my solder under the camera. Let's hope it works. Okay, so I'm hoping to get all this right, so, and without bumping the camera to death. So what I do, I would say what most every tech does, come in with your solder, and you're going to want to get fresh solder really good on all of these, and it's okay if you bridge them and glue it between them, that's fine. So what that's doing is leaded solder is lower melting point temperature than lead-free solder, which is what this is made with. So then that combines the two and lowers the melting point, so that when you go in here to go to suck it, it does a better job of cleaning out the hole. So hopefully you can see there, and then I do two at a time because they're close together with my big soldering iron here. And get in here and suck it out. And can you see? Well, I'll hold the camera up. Oh man, I just whacked you guys. Sorry, right in the nose. That had to suck. Sorry. We'll get a tissue and you can hold it on there. So let's go through and we'll get this last one. And so, see if I pick this up and you guys can see on top. Real careful like. See how it's cleaned up most of the solder out of those holes? So then, depending on how well you do it, how well it comes out, I'll take my brush and wipe away any solder goo that may have fell out of the solder sucker. And then you can always take your solder wick, if you see some real offensive solder still there, try to suck up anywhere that you see that it really needs it. I'm going to nip this off. I kind of already did that to the other ends. We want to get it as cleaned up as possible. You know you ain't going to get it perfect. Man, if you could get it perfect every time, anybody could do this. So this is definitely a point in place where you take your time and you get cleaned up. So, all right, so that was those holes. So I'm going to switch back to full work, and we'll move that around if we have to. Now I'm going to take a box and set it up underneath here to raise this end up as best I can and try to keep it level and not super flex this board. But I want to be able to get underneath here and wiggle, and I'm probably gonna bring this cam back in so maybe you can see these pins wiggle. Let's see if that cam will. There is. We may need a fit or two to tilt this back up again like I had it. Is that a good shot? Yeah. Okay, and so we're going to wiggle this board underneath, and right now it does almost basically no wiggling because there's too many places where it's held on. So if you watch one view, move this out of my way so I can get one hand under here to wiggle. And I'm just going to start touching my soldering iron across here. You will see some of these start to wiggle. You kind of press on them with your soldering iron. And what you're doing is melting that solder and then not allowing it to grab again. And if this doesn't work, there's one other way to do it, and that's use solder alloy. And I got that too. But if you can get it to work this way, See, I see a place here where there's too much solder down in there. And that really needs to be solder wicked. There we go, that helps. So what you're looking for is the gentle wiggle. And you're going to get to see it on that other side. You kind of push with your soldering iron too. You're hoping to get that solder to flow. You push the legs around and they keep wiggling while that solder hardens, and it won't do it. This one's being a bear. It's awfully big. I may have to go to the alloy. I'm not sure if I've showed that in the video yet or not, using the solder alloy. I have to use it on the newer Rockfords. I'm going to go through here and we're going to solder wick this one more time, all along here. This one right here definitely needs it from this side. We're just going to take our time. We're only heating up these pins. I'm not touching really the board. Letting the braid touch the board. Alright. So now, let's try this again. What you're trying to do is push the pin away from any edge that it's touching so that it gets to wiggling. And it just stays a wiggling. This one's going to be tough. It's well worth it to take your time. You don't want to put big stress on nothing. I want to prove that it can be done. I may end up editing all this out because it may just be boring as heck to watch. I don't know. Like I said, you push it away from any edges that it may be holding on to. When you see them all just the gentlest little wiggle, you move on. Once you get them all where they just wiggle a tiny bit, then you'll actually get the whole board moving, and it'll be easy to do. And then you can do some bigger wiggles. I'm not sure, can you see that? Wiggling? I know this one's not wiggling. I'm about to start debating my life choices here. This one's not coming out as easy as some of them have in the past. Of course, this is the biggest one that I know of. The one that does 4 of them on there is the biggest card there that I know of. The last one I did only had 2 of the driver sets, so there was less to do. It was a little bit easier. I may have to get the alloy on this one. And so what the alloy is it's called quick chip. It's for chip removal, stuff like that. You can go in and easily remove it. Really lowers the soldering or the melting point. Dang, really low, and it actually helps kind of hold all that heat to the stuff. And so, like in a big row like this, you'll be able to run your soldering iron back and forth, and even once your soldering iron's gone, it'll stay liquid for quite some time, and allowing you to go through and run your soldering iron as quick as you can, get the wiggle in it, and get it to drop out while you kind of keep heating it. Or you can heat it with your hot air back and forth. And one of the big things it's used for is really hard pin setups like this. And then if you're wanting to salvage chips off of a board, so say like the chips we're going to be taking off of this one, if we considered them still good and we were needing to salvage them, we would use that chip quick on there. We'd use our soldering iron to add that chip quick so that we would put less heat from the hot air to take it out. So I think, yeah, mate, can you see that? Yeah, they're all wiggling in there just a little bit. And so where are we at on the middle? We need to get this one still. That one needs a little desoldering. I may have just bumped that cam. Get myself a little better positioned for the middle here. And as you can see, as they all start to wiggle, you get more and more wiggle. We can come over here, and a few of these aren't perfect. That whole board will start wiggling better and better. You'll find the ones that are holding you up, like that one right there. And what that does, that allows that solder to, when you get it hot, allows it to flow, and your wiggling makes it, whenever it just starts to cool to where it starts to harden, you're pushing it back and forth, and it keeps it away from the holes. So we are wiggly. This is where sometimes I even have to get out my little thing to see which ones are wiggling the best and which ones are not. They all look good from here to there, but we still got one here that is giving me a little trouble right here in the middle. And it needs solder wick, actually. I can see extra solder down in there. Alright. Once you get it wiggly, they're all broke free. Just give it a wiggle back and forth. You'll see. Make sure you gotta look at it the right way to make sure all the legs are moving. Once they're all moving right, you can put a tiny bit of pressure going down. And normally they'll just slip right on out. We're wanting the vias to stay intact. And so just give it a poop. And then, if I can bring it down here, there we go. And you'll see that every leg came out perfect with no torn up vias.